Hello, math people. So today we're going to be doing 5.5, and this is trigonometric equations. We're probably only going to be able to get through about half of this for today, and then tomorrow I'm going to post the second part. But our objectives for now are to solve trig equations for all possible values, to solve trig equations with complicated inputs on the unit circle, to use trig identities and factor trigonometric polynomials, and to use inverse trig and the properties of sine and cosine to solve for all solutions on a certain interval. So recall that sine and cosine are cyclical, right? So they repeat their values every 2 pi, right? So here is 1, and here is 1, and here is 1, and it's all 2 pi apart, right? So they loop over and repeat themselves every 2 pi. Which means if we found x as a solution to sine of x equals something, then so is x plus 2 pi, x plus 4 pi, x minus 2 pi, and so on. So as an example, we want to find all solutions, which means every possible one in all the real numbers, to sine of x is equal to the square root of 2 over 2. So our first step is going to be to look on the unit circle and find all angles from 0 to 2 pi that solve this, right? So I want x to equal, so again, look on your unit circle and try to solve this yourself first. You should get that x is pi over 4, and that x is 3 pi over 4, right? Now that we have these two values, and these are the only values that solve this on this unit, so that would look like something like this right here, right? So, right, we're looking for all sine values from 0 to 2 pi that lie on this line, right? And those are these two values right here. So this is pi over 4, and this is 3 pi over 4, right? And those are the only two values, if you notice, that occur in this 0 to 2 pi interval, right? So we know that all solutions are going to be these values plus 2 pi n. So pi over 4 plus 2 pi n, and comma 3 pi over 4 plus 2 pi n. And if you put that in Pearson, it's going to be happy with you, and you're going to get the question right. So let's do another example, but a bit more complicated. Let's find all solutions to this scary looking equation. 2 cosine of theta minus 5 is equal to negative 3 cosine of theta. You may look at this and start to lose your crap because hey, this is kind of weird. Why are there cosines on both sides? But let's just treat it like cosine of theta was a variable. So if we wanted to solve 2x minus 5 equals negative 3x, right? All we would do is we would add 3x to both sides and add 5 to both sides, right? And we get 2x plus 3x equals 5, or 5x equals 5, right? Which means x equals 1. So let's try that here. But instead of x, we're trying cosine of theta. So I'm going to add 3 cosine of theta to both sides. And I'm going to get 5 cosine of theta minus 5 equals 0, which means that 5 cosine of theta is equal to 5, or cosine of theta is equal to 1. And look on your unit circle and try to find all values from 0 to 2 pi, but not including 2 pi that line up with that. This corresponds to theta equals 0. And so it's going to be theta equals 0 plus 2 pi n. And these are going to be all our solutions. And you can see on this graph that I wrote here, so cosine is in yellow, it's 1 here at 0, and then it's not 1 again until 2 pi, and then it's not 1 again until 4 pi. So this makes sense on a graphical level, right? So our next example is to solve this equation on the interval 0 to 2 pi. So we're not caring about anything outside of the unit circle. So sine of theta is equal to 1/2. Use your unit circle to find this out. You should get that theta is equal to either pi over 6 or 5 pi over 6, right? And there we go, we're done. Those are the only two angles that works for. Now, what if instead we wanted to find the sine of 2 theta is equal to 1/2, right? So in this case, we're still trying to solve for theta on the interval 0 to 2 pi, right? But we know that 2 theta is then going to be from 0 to 4 pi, and so we need to kind of broaden our search, right? I don't want to use an identity here, right? I don't want to expand this out and try to confuse myself more. I just want to use my unit circle to my advantage and go, hey, if 2 theta is equal to pi over 6 or 5 pi over 6, right? Then this equation is satisfied, right? That's what we found in the last problem, right? So in this case, we have if theta is pi over 6 or theta is 5 pi over 6, then that sine of theta is 1/2, right? So if 2 theta is 5 pi over 6, then sine of 2 theta is the sine of pi over 6, 5 pi over 6, or pi over 6, like, right? Which is 1/2, right? So those would solve it. So we're looking for the values for 2 theta, where it's equal to pi over 6 or 5 pi over 6. But remember that those are the theta values from 0 to 2 pi. But we can actually go even further, because 2 theta, we're going to extend our search from 0 to 4 pi. And so whenever you have the inside as 2 theta, 3 theta, 4 theta, 5 theta, we're just going to add 2 pi however many extra times. So because it's 2 theta, we're only going to add 2 pi once. So if we add 2 pi, and this will look more clear in the second problem. If we add 2 pi to pi over 6, we're going to get 13 pi over 6. And if we add 2 pi to 5 pi over 6, we're going to get 17 pi over 6. You can verify that yourself. And then to get back the theta values, all we're going to do is divide by 2. So that means that theta is going to equal pi over 12, 5 pi over 12, 13 pi over 12, or 17 pi over 12. And these are solutions, right? So to get more comfortable with it, what if it's sine 3 theta instead, right? So we know that 3 theta is either going to equal pi over 6 or 5 pi over 6. But we can add another 2 pi and still have theta be between 0 and 2 pi, right? So if we add 2 pi, we're going to get, again, the 2 that we had before, so 13 pi over 6 and 17 pi over 6, right? And then we can add one more. So if we have another 2 pi over 6, or if we add another 2 pi, we're going to get 25 pi over 6 and 29 pi over 6, right? And my Apple Pencil is really glitching out right now, which is not fun. And then to find theta, we're just going to divide all these values by 3, right? So we're going to get theta is equal to pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18, right? I don't know why it's making these dots over here. Does this sort of make sense, right? So we're saying 3 theta can either be like one of these, the ones that we found on the unit circle. But because it's 3 theta, we're going to go around 2 more times, right? Because we can go a full 360 times 2, right? We can go around the circle once, twice, 3 times. And if we divide by 3, theta is still going to be from 0 to 2 pi, right? So if it was sine of 4 theta here, right, then we would just add another 2 pi, right? And we would get 37 pi over 6 and 41 pi over 6, right? And again, we can just keep doing this as long as we need. But in this case, since it's just 3 pi, let me just delete all of these. These are going to be our values, right? So moving on to our next topic, we're going to recall that tangent repeats every pi values, right? So it has asymptotes every odd pi over 2, right? So we have pi over 2, negative pi over 2, negative 3 pi over 2, 3 pi over 2. And so the distance between all of these is pi, and we know that at every pi interval, right, it's going to repeat itself. So solving tangent is actually a bit easier. So we only need to find one solution on the unit circle, and once we have that, we can find the other by adding pi. So for tangent of theta equals root 3 over 3, right? Look on your unit circle and try to figure this one out. So one solution I found is going to be pi over 6, right? And if we add pi to that, so plus pi, we're going to get 7 pi over 6. And these are your two solutions on the interval 0 to 2 pi. So your next example, what if instead it was 2 theta, right? What we're actually going to do is we're going to take the two values that we found before, pi over 6 and 7 pi over 6, the two values that were on a unit circle, and we're going to do the same thing we did to cosine and sine. We're going to add 2 pi. So pi over 6 becomes 13 pi over 6, and I don't know why I use pi over 6. I should have used something else. I'm going to say, what if it was root 3 instead? right? Just so that we don't reuse the same values. So if we want to solve for tangent of theta is equal to root 3, find a value on your unit circle, you should get theta is equal to pi over 3 now. And that's going to imply that if we add another pi, 4 pi over 3 is a solution. And so we're going to, these are our two solutions on this interval, right? And we're going to use these to generate another set of solutions. So if it's 2 theta, we're going to add 2 pi again. So we're going to have 2 theta is equal to the values we found before, pi over 3, or 4 pi over 3. And then if we add 2 pi to these ones, we're going to get 7 pi over 3 and 10 pi over 3, right? Sorry, math brain is mathing. So once we have these two values, we're done, and we stop. And these are going to be the 4 values that solve this equation. Oh, but this is 2 theta, right? We want to solve for theta, so we're just going to divide all those values by 2, right? So we're going to get pi over 6, 4 pi over 6, 7 pi over 6, and 10 pi over 6. And you can simplify these if you want. So another example, we're going to solve the equation on the interval 0 to 2 pi, and we're going to have the tangent of 4 theta is equal to 1. So in this case, one of our theta, so we want 4 theta to equal, find one value in the unit circle that works with this, right? So if we have 4 theta equal to pi over 4, then this equation is satisfied, right? And then we're going to add pi to that to get 5 pi over 4 as our second value, right? Now, again, because it's 4 theta, we're going to keep adding 2 pi until we have 4 things here. So if we add 2 pi to this one, we're going to get 9 pi over 4 and 13 pi over 4, right? Adding another 2 pi, we're going to get 17 pi over 4 and 21 pi over 4. And finally, adding one more 2 pi, we're going to get 25 pi over 4. Again, my Apple Pencil is really not having it with me today. And 29 pi over 4. And again, we need to translate back into our theta values. So we're going to divide everything by 4, and we're going to get theta is pi over 16, 5 pi over 16, 9 pi over 16, 13 pi over 16, 17 pi over 16, 21 pi over 16, 25 pi over 16, and again, if it will cooperate with me, and finally 29 pi over 16. And you're going to just have to ignore these. I'm going to restart my iPad. So I'm going to leave it at that. We're going to get to the next section once I restart my iPad, and I have had some time to go over this. I hope that these sort of make sense to you, right? So again, over here, we solved the case when it was just tangent of theta, and you guys understand that, right? So we're just finding all the values in the unit circle that work for that. But when it's 2 theta, we can let 2 theta equal those two values on the unit circle that we found, right? Or we can add another 2 pi, and the resulting thetas are still going to be between 0 and 2 pi, and so they work, right? And we just do that as many times as we need until all of our theta values, are going to lie in that interval. Yeah, so this has been the first part of section 5.5, and we're going to get to the second part once my iPad has had a chance to chill down. Thank you.